Hey everyone, I hope you're doing well. It's Mr. Irwin back with today's lesson for you. Today we are going to use the skills we learned in our previous lesson about solving proportions and use that strategy as a way to solve word problems. So grab a sheet of paper, grab a notebook, get a pencil, even a calculator, follow along and work through these with me. Our very first example is on the screen. It says the local aquarium has a 50-gallon tank that will hold 22 jellyfish. Next month, the aquarium will upgrade to a 2,800-gallon tank. How many jellyfish will be kept in the new tank? Now, because this is a word problem that features two quantities or two numbers that are being compared to each other, in this case, gallons and jellyfish, I can use a proportion to solve this problem. It's a three-step process. In red down below, you see the three steps we're going to work through. And step one is to find the initial ratio in the problem. Initially, in the beginning, what two values are being compared to each other, or what two values go together. And if you read our first sentence, it says a local aquarium has a 50-gallon tank that will hold 22 jellyfish. So that's going to be our first ratio. We are going to write a 50-gallon tank, and we're comparing that to 22 jellyfish. Now, when you are setting up your ratio, it is extremely important that you label the numbers in your ratio. Don't just write 50 to 22, write 50 gallons to 22 jellyfish. Because when we label our values, when we label our numbers, that gives us a format that we need to follow throughout the entire proportion. Because step two is to set up the proportion. If you remember from our last lesson, a proportion is a set of two ratios that are equal to each other. So I'm going to write my equal sign, and I'm going to write the fraction bar for my second ratio. Now, during this second step, we need to find the other ratio in this proportion. If you read through the rest of our problem, we know that next month the aquarium will upgrade to a 2,800-gallon tank. Well, I know I'm going to use that number in my second ratio, but this is the part you need to be very careful with. Will that 2,800 go on the top of our second ratio or on the bottom? And here's where the importance of labeling comes in. If you notice, our first ratio has gallons on top and jellyfish on the bottom. Because that's how we set up our initial ratio, we have to follow that exact same format in the second ratio. So the top number will have to be a number of gallons, and the bottom number of our second ratio will have to be a number of jellyfish. So, based on that information, where is the 2,800 going to be placed? Because it is a measure of gallons, it will be on the top of our second ratio. Now, the bottom of our second ratio is blank because we do not know how many jellyfish can fit in a 2,800-gallon tank. And because we don't know that value, we're going to represent it with a variable. I'm just going to do a variable x. X representing the number of jellyfish that will fit in a 2,800-gallon tank. Once you're to this point, you're ready for your third and final step. We just need to solve this proportion like we did last lesson. I'm going to go ahead and use cross product method, starting with the diagonal with my variable. 50 times x is 50x. We drop our equal sign. My other diagonal is 22 times 2,800. I'm going to grab my calculator to work that out. 22 times 2,800 gives us a product of 61,600. Solving the equation now, I want to isolate the variable x. It is being multiplied by 50. The inverse is to divide by 50. Whatever I do to one side of the equation, I'm doing the exact same thing to the other side. I'm left with x equal to, and now performing my calculation on my calculator, 61,600 divided by 50. 61,600 helps if I type it in correctly, right? Divided by 50 gives me a result of 1,232. Now remember, this is a word problem. This solution of 1,232 has meaning, so make sure you label it appropriately. The 1,232 is the number of jellyfish that will fit in a 2,800 gallon tank. So I'm going to label that as 1,232 jellyfish. On to our next example. A map has a scale ratio of 1 inch to 200 miles. What is the actual distance between cities that are 9 inches apart on the map? Hopefully you have a sheet of paper. Go ahead and start setting up this proportion with me. Step one is to find the initial ratio. And in this example, it's kind of a gimme. Right at the very beginning, they tell us that 1 inch represents 200 miles on a map. So my first ratio is 1 inch to 200 miles. Step two, we're setting up a proportion. So there's my equal sign and there is my second ratio. The other value in this problem, what is the actual distance between cities that are 9 inches apart on the map? So where is that 9 going to be placed? Will it be on the top? Will it be on the bottom? Look at our formatting from the first ratio. Inches on top, miles on the bottom. 9 is a measure of inches, so 9 inches shall be on top of my second ratio. The bottom is an unknown. I'm going to use... Let's use M for miles. M representing an unknown number of miles. The number of miles between cities in real life that are 9 inches apart on a map. Once we have our proportion set up, let's go ahead and solve it. I'm doing cross products. I get 1 times M is 1M. And remember, 1 times a variable is just that variable itself. So I can drop my equal sign. My other diagonal, 200 times 9 is 1,800. Because I really have nothing to solve, M is already by itself. My solution is M equals 1,800. Don't forget to label that solution. What is the 1,800 measuring? It is a number of miles. That's how many miles those cities are actually apart in real life. Next example. Drew typed 3 pages in 18 minutes. How many pages can he type in 33 minutes? Working through that 3-step process to use a proportion to solve this problem, I'm looking for an initial ratio, 2 quantities that are being compared to each other. I see them right at the beginning. I know that Drew can type 3 pages in 18 minutes. So go ahead and set up your first proportion on your sheet of paper. 3 pages in 18 minutes. Step 2, we need to create a proportion out of this ratio. So I'm going to put my equal sign and the fraction bar for my second ratio. And now we're looking for another value to use in this proportion. The question says, how many pages can he type in 33 minutes? So 33 is going to be the third value of this proportion. Will the 33 go on the top of our second ratio or the bottom? Look at your labels. Our initial ratio had pages on top, minutes on the bottom. Because 33 is a measure of minutes, it needs to go on the bottom to match minutes in the first ratio. Up top, we have an unknown. The top of these ratios is representing pages. And if you can actually see this in the question, it says how many pages. It's asking about pages. The pages are unknown. I'm going to use the variable p to represent the unknown number of pages that Drew could type in 33 minutes. Proportion is all set up. Let's go ahead and solve this. I'm cross multiplying, starting with the variable 18 times p is 18p. Bringing over our equal sign, my other diagonal, 3 times 33, use a calculator if you need to. You should get 99. Next step, solve for p. Dividing both sides of my equation by 18 leaves me with p equal to, I'm going to grab a calculator to double check this, 99 divided by 18, you should get 5.5. Don't forget to label that solution. What did p represent? It was a measure of pages. So in 33 minutes, we could expect Drew to type 5.5 pages. All right, on the screen we have one I would like you to try on your own. It says Jason bought a 12-ounce can of corn for 89 cents. How much would an 18-ounce can of corn cost? Go ahead, pause the video, set up an initial ratio, use that to create a proportion, and then solve that proportion to answer the question. When you've completed your work, begin playing the video again to check to see how you did. All right, so our initial ratio. We know a 12-ounce can of corn costs 89 cents. So that's going to be my first ratio, 12 ounces to 89 cents. Setting up my proportion, my other value in this problem is 18 ounces. Ounces is on top of the first ratio, so my 18 ounces will be on top of my second ratio. And then we have an unknown cost for that 18-ounce can of corn on the bottom of our second ratio. I'll use the variable C. Cross multiplying then, 12 times C is 12C equal to, then we're doing 89 cents times 18. So I type in 0.89 times 18 into my calculator. I get 16.02. And now we're solving for C by dividing both sides of the equation by 12. We get C equal to 16.02 divided by 12 is 1.335. Don't forget to label your solution. This is an amount of money, so I would label this as dollars. And when you do that, you should notice something's up. $1.335. If I'm talking dollars and cents, I need to round this value to the nearest cent. For money, how many digits do we keep for cents normally? The first two digits after the decimal point. In this case, it's 33. But because I have a third digit, the 5, I'm going to use that 5 to round my cents. So how would a 5 round my 33 cents? 5 and above, give the 33 a shove. So we would round this to $1.34. One more proportional word problem for you to try on your own. A 64-count box of crayons contains 3 shades of green. How many shades of green would you expect to have in a box of 256 crayons? Go ahead, pause the video, find your initial ratio, set up a proportion, and solve that proportion to find the solution of this word problem. When you finished your work, start playing the video again to check to see how you did. Okay, here we go. Let's go over this. Our initial ratio, I know a 64-count box of crayons will hold 3 shades of green. So 64 crayons would have 3 shades of green. I'll just say 3 greens. Question says, how many shades of green would you expect to have in a box of 256 crayons? 256 is a number of total crayons, so it's going to go on the top of my ratio, 256 crayons. And I'm going to use G for my variable because it represents an unknown number of green crayons. Solving this, 64 times G is 64G. The other direction, 3 times 256. 3 times 256 in my calculator, 768. Let's solve this equation by dividing both sides by 64. And you should get a solution of G equal to 768 divided by 64, 12. So your solution, 12 shades of green.